two. Hello.
Hello.
Hi, April.
Hi.
How are you today?
I'm all right.
I'm
Although I turned on 106.9 last night, the radio
yeah,
station. They're
yeah.
playing Christmas music.
Oh, they do that 3 months. Yeah, I know. Yeah,
You know,
yeah, yeah.
I have my windows open. It's nice breeze outside. Can I just enjoy fall? Is it
Yeah.
asking too much?
I used to work for a place that they'd start playing that nothing but Christmas music like as soon as they started doing that 106.9, and after a few days it'd start to get a little bit weird, like, you know.
Yep. Oh my gosh.
I'm here today, but like if I ever have to miss again, does that count against you as long as you watch the
No.
video from? Okay, I just wanted to be sure on that.
Nope. Nope, nope, nope. Let's see. I need to open my PowerPoint. Now that I think about it. And I didn't finish the PowerPoint the other day, as I recall. Ivy Tech.
Have you heard that they're going to do next semester like they're doing this semester, and it's all going to be, for the most part, the Zoom classes, and they're not going to have hardly any face-to-face classes? Have you heard about that?
No. Is that what
Yeah,
you heard? Or you asked?
I heard it from my tutors at Ivy Tech in Sellersburg. Now, it might be different at IUS. I don't know. I'm going to IUS next semester. I hope it is. But like I said, for the most part, it's all going to be like it is now, which I think is ridiculous. I just, that's just me, though. I know everybody's different.
IUS gave each individual instructor their own choice as how they wanted to do it.
Yeah.
Which was nice. So I know I've chosen to go all online, so I'm not even doing this. I've created videos for my classes, short little videos, and they can watch them in spurts. And then I have Zoom office hours. So if anybody needs help one-on-one, they can come to my office hours and make an appointment. But
Yeah.
I've not heard anything about Ivy Tech. I taught at Ivy Tech from 2006 to 2014, and then I left and haven't been back until this semester. So
Yeah, it's a pretty good school.
I haven't heard anything. So, and I don't even know if I'll be teaching again next semester at IUS, Ivy Tech, but I'll be at IUS for sure. And I know most of the other lower level math have chosen to teach online. We do have one instructor who's teaching in the classroom. But I think she's doing it like a split where half the class comes on one day and the other half comes on the other day, because unfortunately we have no control over the people in the classroom. The school has dictated that you can only have X number of students in a class. You have to social distance. And I don't know if that's what's going on right now, because she's teaching in the classroom right now. But again, for spring, I don't know about if they're going to go back to 100%, but we had to have our schedules set. So I know
I really feel bad for people in high school. They can't have a prom. That's like, what, and they're taking away our spring break. Just because we have spring break doesn't necessarily mean we're going to, there's no correlation. I mean, there's no direct cause and effect. There's a correlation, but some people just relax, I don't see how it just seems so screwed up.
Yeah, I know the first 3 weeks of spring semester at IUS are mandatory online. And then after that, you can decide what you want to do. And I've done so much work to be online this semester, and I'm going to be forced to be online for the first 3. I thought I might as well just, continue on.
I hear you.
Yeah, I had a son who just graduated from Floyd Central, so he didn't have a prom, and they finally had graduation, but they had to do it in 2 days. Half the class went or actually it was the same day, but half the class graduated at 9 in the morning and the other half graduated at 11. So, and they had them all spread out. And So he was okay. He was actually wasn't even gonna go. He's like, I don't care. And I was like, you're going. So anyway, fun times. I forgot to do this. There we go. And I forgot to do that. And we were here doing this. Okay, so this was the last thing I did. I'm talking to myself. All right, it's 4:05, so I'm gonna go ahead and start. This was the last slide I did on 3.5. So I still had 2 more examples to cover real quick. Number 19 says graph the following function using the techniques of shifting, compressing, stretching, and or reflecting. And you start with the graph of the basic function. And the basic function is y equals the square root of x, which is this, you know, whoop, over there. Because you can see you've got the square root of x right here. But they then put a -1 under the radical. Okay, let me get my pens going here. So that means that the graph, let's see, this is pink. This graph over here would go 1 to the right. So my graph starts at the origin, it would go 1 to the right. Oh gosh, that's so tiny. Let me draw my own graph. So the original graph is doing something like this. And then because of the pink, it's going to go 1 to the right. So it's going to start here and go to here. So it would move like that. And then because of the +5, that means it's going to go up 5 units. So I need to draw my graph a little bigger. 3, 4, 5. Okay, so it's going to go from here up 1, 2, 3, 4, 5. So now it's like that. And last but not least, there's this 2 in front of it. So that means it's going to shoot up a little bit closer to the y-axis. So this point won't move. Whoops, switch to blue, sorry. This point won't move, but this is gonna stretch up a little higher than it was. So looking at all the pictures, the only one that makes sense is D, because that's in the first quadrant. My final starting point, you know, this point right here, that's in quadrant 1. This one here, that's in quadrant 4. This one's in quadrant 2. This one's in quadrant 3. This is the only one that's in quadrant 1, so it's got to be that one. Okay, and then they want to know what's the domain. Well, remember your domain is all of the x coordinates. So from this picture, since I know it's D, my graph, which goes like this, is all of my x coordinates going this way. Starting at the very first one, which is the, this is where it starts. Horrible line. Which starts at +1. So the domain starts at 1 and goes to infinity. And then they want to know the range. Well, the range would be, Okay, let me erase the purple. The range is what the y's are. So the lowest y is right here, and then it's going to keep going up. So the range keeps going up and up and up. So I did a horrible job on that one too. The lowest point is right here. And the lowest y coordinate is, what was it? It was 5. Yeah, the coordinates of my vertex right here was x is 1, y is 5. So 5 is actually the smallest number in your range. So let me get a gray pen here. So my range starts at the 5, and it too goes up to infinity. Because in this graph here, not only are you going to the right, but as you go to the right, you go up. So you're heading towards infinity to the right, but you're also heading towards infinity up high too, as you get further and further and further away from, you know, the origin there, or from the starting point at 1, 5. Okay. And then there's another one, I think, just like that, where they ask you to, yep. And you can see they're starting with the same basic graph, which is y equals the square root of x, and it's this line right here, okay? And I can see I've got the square root and I've got the x. So that's the basic function. But this one, they have put a negative underneath the radical. And when that happens, this thing flips like a weather vane. It spins like a weather vane. So my graph, because of the pink, this thing is going to spin 180 degrees, and it'll now be on the other side. And then because of this -5, which is not under the radical, it's outside the radical. So it's saying, take your square root of x and then drop it down 5. So this pink one's now going to go down 1, 2. Oh, these are labeled by 2s. Okay. So 2, 4, here's 6. So 5 would be right in the middle. And it's going to look like something like that. The green is my final answer. So looking at all of my choices, the only one that makes sense is B right here. That's got to be it. And then I just have to look at that graph and ask myself, well, what's the domain? And the domain would be, let's see. So I'm at 1, 2, 3, 4, 5. So here's my graph. Goes like this. This point right here has the coordinates of x is 0 and y is -5. Because this starts on the y-axis and goes to the left, your x coordinates for all of the points are right here. Every single point on this graph has an x coordinate to the left of the origin. So my domain actually starts way down at -infinity, comes up to the 0, and it does include it because it was a solid dot. Now the range, okay, the range is low to high on this graph because I have a low point. That 0, -5 is the lowest possible point. So my range starts at the -5 and includes it, and then goes all the way up to infinity. Your range starts right here. And of course, this graph has y coordinates that keep getting higher and higher and higher. Every one of these points, the y coordinate is above that horizontal line I just drew there. So it starts at -5 and goes to infinity. And that finishes that section. Anybody got any questions on that? All right, close that one out. And now I'm switching to this one. All right, so we are in chapter 4, and this is the last section we're going to cover before your midterm exam. So next week on Monday, we'll review, and on Wednesday, we take the exam. And from what I understand, the exam is over Zoom, and I sit here and watch you. I'll get more information, and I'll set an announcement about that so you guys have more information. All right, so in section 4.3, we're going to mess with quadratic functions and quadratic functions only. Remember, quadratic functions are, you know, y is equal to something x squared and a something x and a something, but it's the x squared that makes it quadratic. You might not have the x, but you have to have the x squared. And we're actually going to do all 5 of those objectives right there. So fun is about to be had by all. All right, so here's the definition of a quadratic function. A, B, and C are real numbers, but A is not allowed to equal 0, because if A was a 0, you wouldn't have an x squared. Then you'd have a linear function, because you'd have a something x. But B can be 0 and C can be 0. I mean, you can just have, and we've been messing with them, you can have just y equals x squared. That's the basic function. All right, so the graph of a function using transformations, just to go back over this again, this is the function of f of x equals 3x squared. This was the original, which is in black right here. And then they just showed you that if you change the coefficient to a 1, let's see, the blue one has a 1 right here. And you'll see that the graph, it went from 3x squared to only 1x squared. So it starts to fan out. And then they switched the coefficient to a 1/2. They made it even smaller, and you can see that it's starting to fan out even more. Starting to look more like a bloomin' onion to me. I'm hungry. Time to go to Outback. But they're just showing you how it can, you know, compress out or stretch up. Okay, and then the only difference with this, it's the exact same 3 graphs, except they stuck a negative on them. And all it did was flip them all upside down. Okay, and then we've talked about this before. Axis of symmetry is simply, it's an imaginary line that cuts the graph in half so that if you were to fold it along that line, the right side would match up perfectly with the left side. Now, this slide talks about the graph opening upward. I'll just do it. This is opening upward, but this is also called concave up. It's kind of like a spoon, you know, if you have a spoon and you're scooping up your cereal, the spoon has to be like this in order to get the cereal in it. It's concave up. But if you flip your spoon over, they're saying that this opens down. This is called concave down. Other words for you. You're going to see them in my math lab, so I'm talking about them. Because if you turn your spoon upside down, you know, the cereal is going to fall out. So, and also, I can just look at the graph. If my A, or not the graph, I'm sorry, the equation. If your A, which is the coefficient on your x squared, You know, the equation's going to be something x squared, blah, 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 blah. If the a is less than 0, which is a fancy way of saying negative, it'll be concave down. And if the graph, if the equation has an a that is greater than 0, which is a fancy way of saying it's positive, then it's concave up. All right. Now, we are now going to identify the vertex, which, sorry, I forgot to talk about that. Back here on this picture, on the green one, the vertex is actually your lowest point right here. That is also called a minimum. And on the other one, the vertex is actually the highest point right here, which is a maximum. All right. Okay, so identify the vertex and the axis of symmetry of a quadratic function. There are actually 2 ways you can do this, and it depends on how the equation is given to you. This is called standard form. When you have an equation that looks like this, they call that standard form. You'll have a something x squared, and then maybe a something x, and then maybe a something. B or C could be 0. You have to at least have the ax squared. To calculate the vertex, your vertex is going to be calculated by taking negative b and dividing it by 2a. And then they say that the y coordinate is f of negative b over 2a, which is a fancy way of saying take the value that you just calculated for x and plug and chug it here and calculate the y coordinate. And then, of course, the axis of symmetry, once you have the x coordinate, that is your axis of symmetry. You'll just say x is equal to whatever I got when I calculated negative b divided by 2 times a. And then the same thing I just talked about a minute ago, the parabola opens upward or is concave up if your a is greater than 0, which means it has a minimum point because it's concave up, so it goes like this. So it has a low point. And the parabola opens down or concave down if a is less than 0, negative, which means, you know, it's humped and you've got a high point, which is your maximum. Now that's called standard form. It can also be presented to you in what they call vertex form. And that is when they take the ax squared plus bx plus c, they actually do something called completing the square, which I kind of left that out of the explanation because when I looked at my math lab, it didn't look like you needed to do it that way. But you might have some that are presented to you like this, and we did, because when it's like this, we were able to shift it, you know, left and right. The K made it go up and down, and the H made it go left and right. But when it's in this form, whatever number is right here, the H, that is the X coordinate of the vertex. And whatever number is right here for the K, and it says plus K, but you could have a minus K there. So you could have a negative K. That is the Y coordinate of the vertex. Now, the standard equation does have an X minus H, but you just pull out the H unless it has, if you have like 3 times X minus 5 and you have a plus 4. My vertex here would be 5, 4. But let's say you have this equation where it has 2 times x plus 3 and then a minus 8. You have to see this x plus 3 as an x minus a negative 3, because subtracting a negative is adding a positive. And now my vertex is -3, -8. Let me go back and color these for you. For this one, here's the h, right? Right there, minus h. So you just grab it and that's your x coordinate. And then your y coordinate is the 4. And since it's a +4, I just say that it's +4. But over on the other one, it has to be in x minus h. So since it said x plus 3, I actually have to go with a -3. You know, it's just like when you're shifting left and right, you know, if that said x plus 3 and I was shifting, wouldn't we go to the left? 3 in the negative direction. It's that same concept. So it's -3. And then my y coordinate is the 8, but because it has a negative in front of it, because it does say up here plus k, so if it says -8, you take the minus with the 8, and that's your y coordinate. All right, so example, it says, without graphing, locate the vertex and axis of symmetry of the parabola defined by f of x equals blah, blah, blah. Does it open up or does it open down? So if I were doing this myself, I would say, okay, the x coordinate is going to equal -b over 2 times a. So that's going to be negative whatever b is over 2 times whatever a is. And up here in this problem, my b is the coefficient on the x. So that's what's going to go right here. So that'll be a 6. And then the a, isn't a the coefficient on the x squared? So that's what's going to go right here in the a spot. So that's a -3. So a negative of a 6 is a -6. And 2 times -3 is -6. And -6 divided by -6 is +1. Uno. So there's the 1. I still need the y coordinate. So now I have to go back to the fact that f of x is equal to all of this. So I have to calculate f of x is 1. So this is going to be -3x squared. So that's going to be 1 squared plus 6 times x, which is 1, plus 1. Let's see, 1 squared is 1. -3 times 1 is -3. 6 times 1 is 6. And then add and subtract from left to right. -3 plus 6 is 3, and 3 plus 1 is 4. So there's that. So that is my vertex. And then it wants to know what the axis of symmetry is. So we located the vertex and we need the axis of symmetry. That would just be x is equal to 1. It's the x coordinate. And then it asks, does it open up or down? Since my a is a negative, a is equal to a -3, so down. That's how you do that one. And of course, the next slide shows all of their explanation, which gives the same answer I did. The vertex is located at 1, 4. The axis of symmetry is x equals 1, and the parabola opens down. Vertex axis of symmetry and down. All right, now that's how you do it if it's in the standard form. If it is in the vertex form, it is so much easier because all you have to do is look at the equation. You know, if they gave me y is equal to 2 times x minus 4 squared plus 7, I just have to look at this and I'm like, okay, the vertex is at 4, 7. The axis of symmetry is x equals 4. And because 2 is positive, it's gonna open up. Didn't have to really do much work at all on that one. So vertex form is easy when you have to answer questions like that. Okay. Now, graphing a quadratic function using its vertex, axis of symmetry, and intercepts. And remember, there's 2 intercepts. There's x and y intercepts. And the thing to remember about the x-intercepts is for x-intercept, y is always equal to 0. And for the y-intercepts, x is always equal to 0. That's the thing you have to remember. Okay, starting with the x-intercepts. I can tell from using the discriminant, which is the b squared minus 4ac part of the quadratic formula. You know, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, if you look at the discriminant part, which is just the b squared minus 4ac, the part that's under the radical, and I know I've talked about this before, if you do that calculation, and if the number comes out to be greater than 0, which means positive, then it's going to have 2 distinct x-intercepts. Your graph is going to definitely cross the x-axis twice. Now this example shows it as concave up, but I could flip that over and have concave down, crossing it in 2 places just as easily. It would look like this, crosses here and there. If the discriminant, if the b squared minus 4ac equals 0, in front of the radical you have that plus or minus, you know, it's negative b plus or minus the square root of, well, if the square root's positive, then you do the plus as one problem and the minus as the second to calculate the 2 x-intercepts. But if it comes out to be 0, all you're going to have is negative b plus 0. There's only going to be 1 x-intercept, and that x-intercept is also the vertex. It will sit right on the x-axis, whether it's concave up or concave down, like that. It can do that too. It'll sit right on the x-axis, okay? I didn't do that over here, shoot. And then the last one is if your discriminant is less than 0, meaning it's negative, then you're at the square root of a negative and you're like, wait a minute, I can't take the square root of a negative. That takes me into imaginary land. That means there are no x-intercepts at all. It will not cross the x-axis, which means you got a floater. See, it's just floating above the x-axis. And if it were upside down, it would be floating down here somewhere like that. If you had, you know, a negative a. So just from the discriminant alone, I can determine whether I'm going to have 2, 1, or none on the x-intercepts. Y-intercept should always be 1 because of the way the parabola spreads out. At some point, it'll cross over the y-axis. No matter where the vertex is, whether it's in quadrant 1, 2, 3, or 4, because the graph spreads out, it'll nail the y-axis either on its left or its right somewhere. But the x-intercepts, no, 2, 1, or none. All right, so graphing a quadratic function using its vertex, axis, and intercepts. Use the information from example 1 and the locations of the intercepts to graph this function, and then determine the domain and the range and determine where f is increasing or decreasing. Now, this one is given to me in the standard form, so I'm going to have to start with x is equal to negative b over 2 times a. So that's going to be negative, and my a, or my b, sorry. Here's my b, that's a 6, and my a is negative 3, that goes there. So it's negative 6 over negative 6, which is positive 1. And then the y coordinate is going to be negative 3 times 1 squared plus 6 times 1 plus 1. So I stick the 1 here and the 1 there. So negative 1 squared is 1, times negative 3 is negative 3, plus 6 times 1 is 6. Negative 3 plus 6 is 3, plus 1 is 4. Is that the same one I did before? Okay, so my vertex is 1, 4. And that means the axis of symmetry is x equals 1. And they want to know where the intercepts are. And actually, sometimes I don't even have to do the whole, yeah, I really don't even need to do the b squared minus 4ac. I use my common sense here. Where's the point 1, 4? Over 1, up 1, 2, 3, 4. It's right here, isn't it? So that thing's either going to be a floater or it's going to cross the x-axis twice. It's not on the x-axis. If it were on the x-axis, this guy right here, he would have been a 0. And because this thing, if I look at my A is a negative 3. So that means this thing has to come down like this. It's going to have 2 x-intercepts. The domain will be negative infinity to positive infinity. The range will be from, since it's upside down, my highest point is 4. So the range has to go, if you're going low to high, negative infinity up to the 4. So the domain is negative infinity to positive infinity. And the range, this thing, remember it starts down there. That's where it's actually starting. And it goes up to its highest point, which is at the 4, and it includes the 4, and then it goes back down again. It's really starting down here. It goes up, high point, goes down, go down, go down, go down, when you're going from left to right. And then for increasing and decreasing, the increasing, that's this side. And the decreasing is this side. So it increases. Now if you remember, increasing and decreasing is how this thing moves from left to right, which has to do with the x-axis. So for the decreasing, it goes from negative infinity up to this point right here, which is the x-coordinate of 1, but you don't include that. And then the decreasing is, or oops, I wrote decreasing. I meant to write increasing, sorry. My bad. I said increasing, didn't I? Or did I? I don't remember. I meant increasing. I'm going up the hill. That's increasing. And then over here, we're now going to go down the hill. And that starts on the other side of the one, the red one. And then it keeps going to the right. So eventually it hits infinity on the x-axis. Did I answer everything they wanted? Of course, the next slide shows all their work. Mine's kind of a colorful mess. Let's see. They identified A, B, and C. And they, oh, I never did calculate my x-intercepts. My bad. Okay. I just figured out there were 2 of them. And when they set this equal to 0, unfortunately, that doesn't factor. Ooh. So they had to use the quadratic formula, and then they got decimal answers. So just do whatever my math lab tells you. But you can see there were 2 of them. It says that we found the vertex to be at 1, 4. Oh, okay. That was the same problem. I redid the vertex for nothing. Sorry. I thought that was looking familiar. So the vertex was 1, 4 before. The axis symmetry was x is equal to 1. The y-intercept can be found by letting x equal 0, which gives you f of 0 equals 1. If I haven't said it before, I'm going to say it now. When it's in the standard form, the C right here, that is your y-intercept. The y-intercept is always at 0, and then whatever C is. Because if you stick a 0 here and here, any number times 0 squared is 0. And any number times 0 is 0. And 0 plus 0 is 0. And 0 plus 0 plus C, you're just left with the C. So C is always your y-intercept. Okay, and continued. And then they graphed the 1, 4, and then they graphed the intercepts, which don't come out pretty, which means I don't know if you'll be able to do that in my math lab or not. So what they did is they found the y-intercept. That was pretty. Here it is. Come on. Here it is, right? And then if you look at it, that is just 1 unit away to the left from the axis of symmetry. So it's mirror image. If you do the mirror image on the other side, it's 1 away this direction. And that'll give you 2 really nice points that aren't decimals for the graphing part. I think all you're going to have to do is graph you have to graph the vertex and then 1 other point, because as soon as you plot the vertex, you know, you click on the tool function in my math lab, and it says, do you want to graph a line? Do you want to graph a parabola? And you click on the parabola, the first point you have to graph is the vertex. And then when you start moving your mouse, the parabola shows up, and you just have to get another point on the parabola to make it work. If I got time, I'll pull one up later. Okay, now they want us to find a quadratic function given its vertex and 1 other point. Okay, so this is where we're going to use the vertex form of the line. Okay, if the vertex is HK and 1 additional point on a graph of the quadratic equation f of x equals ax squared plus bx plus c, then we can come up with this. Now, all you have to do is take the h and plug it here, and take the k and plug it there. So why do you need 1 additional point? Because you don't know what a is. Your additional point, which let me put that in a different highlighter color. One additional point, what you're going to have to do when they give me this additional point, which is XY, you're going to have to stick the X coordinate where X is and the Y coordinate over here where the f of X is. Then every single letter has a number in its place except for the A. And then we'll do a little math magic and we'll solve the equation for A. So let's look at their example. Okay, determine the quadratic function whose vertex is 1, -5, and whose y-intercept is -3. All right, I'm going to start with the y is equal to a times x minus h squared plus k. This number here, that is my h. This number here, that is my k. My other thing they gave me, they said it has a y-intercept is -3. I need that ordered pair. That would be 0, -3. And then 0 is going to go where this x is. And -3 is going to go where the y is, or the f of x. And once I plug in all those numbers, all I'll have left is the letter A. So I'm just going to go back to black pen here. Y was the blue, -3. I don't know A. X was yellow, that's 0. Minus H is green, which is a 1. And then plus -5, I'm just going to put -5. So I'm going to start with 0 minus 1. That's a -1. -1 squared means a -1 times a -1, which would be a +1. And A times 1 is just A. And now all I have to do is add 5 to both sides. And I get A is equal to 2. So my final answer is going to be, they probably want it in function form. So f of x is equal to, I just found A was a 2, so I need a 2 here. And then x minus 1 squared minus 5. And that should be my answer. Now that's how I did it. Let's see how they did it. Did they get the same answer? Well, they did right here. Oh, man. Hey, it did not tell me to put it in standard form, did it? No. Huh. Well, I'm guessing my math lab will take it in Vertex form. If my math lab does not specify something, it should take it in more than one format. Now, if it says express your answer in standard form, I got a little more algebra to do. I'm going to act, yeah.
There's 3 forms. There's the vertex, function, and standard, right?
Well, function is just putting f of x in place of y.
All right.
If they want me to put it in standard form, I'm going to have to actually take this x minus 1 and FOIL it out, and then take this 2 and distribute it, and then combine like terms, and I should end up with this. When I get to one of my math lab ones, we'll do it, and then I'll pull up my math lab and see what it does. And then they graphed it. Yep. In my math lab, you're only going to need the vertex here and one other point, which was the y-intercept, and it'll form it for you. And you can see if you draw in the axis of symmetry, which would be right here, this point is 1, 2 to the left, and this is 1, 2 to the right. It's mirror image over there. All right, and then if they ask you to find the maximum and minimum values, that has to do with the vertex. Because if you're looking for a maximum, the maximum is the highest point right here. If you're looking for a minimum, the minimum value is this lowest point right here, and it will be the y coordinate of your vertex. So this one here is you're somewhere on the x-axis, and then you're at a maximum value for y. And this is you're somewhere on the x-axis, but you're at a minimum value for y. So if they ask you for maxes and minimums and they want to know the max and min value, you need the y coordinate of the vertex. So determine whether the quadratic function has a max or a minimum value, and then find the max or minimum value. To do this first part, it's easy. Determine whether it has a max or a minimum. I'm looking at this equation and I know that it has a 1 right here. So that means it has a minimum value because my A is greater than 0, which means I've got this situation. I have a minimum. But to find it, I got to do the math. So I'm going to have to start with the x coordinate is negative b over 2a. You got to find that number, and then you're just plugging and chugging to find the y, which is the minimum. So this is going to be negative of whatever my b is over 2 times whatever my a is, and my b, this is b. B is negative 4, and A was the 1. So this will be positive 4 over 2, which would be 2. And now I'm just going to take this 2 right here, plug it in here, and plug it in there to find the y coordinate. So my y coordinate is going to be x squared minus 4 times x minus 5, and x was a 2. So this is going to be 4 minus 8 minus 5, which from left to right, 4 minus 8 is negative 4, and negative 4 minus 5 is negative 9. So the minimum value is equal to negative 9. And let's see what they did. Well, there you go. They wrote a whole bunch of stuff, but it's still the same thing I did. A was 1, B was negative 4. They stuck it into the x is equal to negative b over 2a. They got x is 2. And then they took that 2 and they plugged it in here and here, which is what they showed right there. And they did the math, and there's the negative 9. Okay, so I am to the point where I can do some of my math lab questions. I've covered all the concepts. I feel like I went pretty quickly though. Does anybody have any questions? Everybody happy? About as happy as you can be in a math class? Oh, look, candy corn. Sorry, if I'd been in class, I could have brought it to share, you know? Oh, well. All right. Number 1. It says, list the intercepts of the following equation. And I always read the fine print in my math lab first. Let's see, if I have any, it'll say type ordered pairs and use a comma to separate answers as needed. Okay then. It's a parabola, and I know that this thing is a smiley face parabola, right? Because it's got an x squared on it. And that's the basic function of x squared, but it's been moved down 9 because minus 9. So remember the basic y equals x squared looks like this. But because they put the minus 9 on it, this thing's going to come down 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to be down here now. So I know it crosses the y-axis in one place, and it's definitely going to cross the x in 2. But the y-intercept, is when x is equal to 0, or you can just see it as 0c. And I can see that c, this is c, isn't it? -9. So my y-intercept is 0, -9. That is one ordered pair that I'm going to stick in here with a comma after it. And then my x-intercept is going to cross in 2 places. That is when y is equal to 0. So I'm going to have to put a 0 right here. I'm going to have 0 equals x squared minus 9. And then you can factor this, or you can solve by taking square roots, whichever way you want to do it. If I factor it, I would have, this is a difference of 2 squares. So I'd have an x plus 3 and an x minus 3. So this x would have to be a -3. So that point would be -3, 0. And this point would have to be, this x would be a +3. So +3, 0. And that's another answer, and that's another answer that I'm going to put in the box. Now I know I wrote a whole lot down, but you know, just so you can see what I was thinking. It took me a little bit to do the problem, but if I were in my math lab, it wouldn't take me as long, as I'm not going to write down a whole lot, because I can see that the letter C is -9. So boom, 0, -9, I'm done. I did have to do the math on the x-intercepts. Number 2 has a drop-down box. So I took a screenshot of it where I showed you what was in the drop-down box, and it's just choices right or left. It says to graph y equals x minus 4 squared, you shift the graph of y equals x squared to the, and because the -4 is inside the parentheses, remember that's going to shift it left or right when it's inside. And because it's a -4, it's actually going to go 4 to the right. So I'm going to click on to the right, and then I'm just going to type in the distance of 4 units right there. That's it. Okay, next question. Determine whether the following statement is true or false. And the following statement is the graph of f of x equals blah, blah, blah opens up. Well, all I have to do is look at the 4. 4 is greater than 0. So it opens up. It's a smiley face like that, right? So true. That was quick. All right, now the next one, you got to read carefully because I clicked on the wrong answer like twice and I was like, what? And then I reread it and I was like, oh, okay. Determine whether the following statement is true or false. Here's your statement. The y coordinate of the vertex of f of x equals blah, blah, blah is whatever f of 4 would calculate to be. Okay, so they're saying when they say f of 4, when they say f of 4, they're stating outright that the y coordinate of the vertex would have an x coordinate of 4, which means I just simply need to calculate, is that right, with the negative b over 2a. So this is going to be negative over 2 times a. When I come up here, b is 8, right? B is an 8. And a, here's a, is that negative 1? That's a, negative 1. So I get negative 8 over negative 2, which equals positive 4. So it is true because the x coordinate of the vertex is 4. That's what they were saying to me. I made it a lot harder when I did it the first time. Does that make sense? The
Yes.
y coordinate of the vertex of blah, 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 blah is f of 4, meaning it should equal whatever f of 4 is. Well, I need to make sure that 4 is the correct x coordinate, because if it's not, then no, that wouldn't be the y that would go with it. Sneaky, sneaky, sneaky. They're making you think. I hate thinking. All right, now when you get to number 9, it's the click and drag thing. I don't know why they labeled them 13, 14, 15, 16, 17. I don't know why they labeled them with numbers. It's problem number 9. So you have to click and drag and pick the right equation to go with this. And I want to, since I don't have much room on here, I'm going to open up my whiteboard. Microsoft Whiteboard, open. The share, go here, whiteboard, and give me a second. I'll reshare this in a second, and it's this one. And I need to make it a little bigger. Okay, and then go to share. Okay, can you see both my math lab and me over here drawn on this?
Yes.
Cool. Okay. All right, so, all right. I have to pick out my graphs one at a time. And when I did it on myself, I was looking at my equations first and going, what's the easiest to deal with? And I determined that this one right here, since it's just an x squared minus 1, I knew that that was going to be this basic graph right here. But it was going to come down 1, so it was going to move to that. So I started with him. And I looked for, it's a positive x squared, so it's a smiley face, but it just goes straight down to 0, -1, and that was choice, this one right here, isn't it? So I can see it's at 0, -1, so it's this one. And then I did the same thing with this one, except this one's a -x squared. So a -x squared would actually be like this. And then because of the -5, this too is going to come down 1, 2, 3, 4, 5, so that it's like that. But the vertex would be at 0, -5. Which would just happen to be the one right next to it, right here. That one's at 0, -5. Now, the next easiest one that I thought was this guy, because his C is a 0. And if the Y-intercept is a 0, that means that it's crossing the origin. But I'd still need to figure out the X coordinate, don't I? Yep, I still have to figure out the X coordinate for that one. So, okay, so for the f of X equals X squared minus 4X, the X coordinate of the vertex would be -b, which is -4, over 2 times a, which is 1. So that's 4 over 2, which is 2. And then if you stick 2 in there, the y coordinate is 2 squared minus 4 times 2. That's a squared, sorry. 2 squared is 4, minus 4 times 2 is 8, which is -4. So the vertex is 2, -4, and I know it's a smiley face, and I know the y-intercept goes through the origin. So 2, -4, 1, 2, 1, 2, 3, 4. My vertex is here, and it's going to go through the origin, and it's a smiley face, so it looks like that. 2, -4, 2, here it is, 2, -4, and it does look like it's going through, so it's this one here. That's my process of elimination, and I just keep going through them. You can do them from left to right if you want. So then I would go to, I don't know, this one's x squared plus 4x. So that would change this to a plus 4. Whoops, new color. Plus 4. This would be a plus 4, which means this would be a plus 4, which means this would be a -4, which means this would be a -2, which means this is a -2 and this is a -2. Wait a minute. -b over 2 times 1 is -2. Oh, yeah, this would change to a plus sign here. So this is still +4 plus 4 times, this would still be -8, and then 4 minus 8 is still -4. So now I've got -2, -4, which would be 1, 2, it'd be over here. Now I'm looking for this, which is this one right here. That's that one. Do I need to keep doing these, or you guys think you understand this?
I think we got it.
Okay, because there's 4 more. I would just do -b over, I just find the vertex, because if you look at them, this one's 2, 0, this one's -2, 0, this one's +2, 1, this one's -2, 1. And if I look at the other 4, they all have a different vertex. So you should be able to match them up. based on the vertex, doing, you know, negative b over 2a to get it done. All righty. I think there's 2 like that in my math lab. Oy vey. Okay, stop that share and just go back to the PowerPoint.
Did you say you're going to give us a review today to go over Monday?
No, I haven't made it up yet. Sorry. Oh, I can't get this to go full screen. All right, close that out and move that. There we go. Can you see the PowerPoint again?
Yes.
Okay, and just PowerPoint. And just so you know, if I were to finish this up for you, instead of doing all the work, just putting the answers out there, this one here, x squared minus 4x plus 5, ended up being this one. And gray, x squared plus 4x plus 4 ended up being this one. And I guess I'll go with navy blue. The x squared plus 4x plus 5. X squared plus 4x plus 5 ended up being this one. And there was one more. Well, obviously. Obviously, this one was this one. There you go. It's the only one left. All right. Graph f of x equals blah, blah, blah by starting with y equals x squared, using transformation, shifting, stretching, compressing, and reflecting. If I were to start with the y equals x squared, and I was old school, which was not on my math lab, since it's a parabola, I would go with x is -2, -1, 0, 1, and 2. When I had to do this by hand myself, you know, the old graph paper, that blue stuff you bought at Walmart, you'd have to graph at least 5 points, including the vertex. And I know the vertex is at 0, 0 because it's that basic graph. -2 squared would be +4. -1 squared would be +1. +1 squared is 1. +2 squared is 4. I would come over here and it would look like this. And then you would have to make the adjustments with this equation here. And because I've got 5 negative, a +5, remember as far as shifting and stuff, the 5 is, since it's a +5, inside the parentheses, that means you're going to shift 5 to the left, and then the -3 is going to be, you're going to drop it down 3. And of course, the new vertex would be -5, -3. But if I start at this point here and I go down 3, 1, 2, 3, and then shift 1, 2, 3, 4, 5 to the left, there's my new vertex. And then if you take this point and go down 1, 2, 3, and 1, 2, 3, 4, 5, he lands right there. And if I take this point and go down 1, 2, 3, and over 1, 2, 3, 4, 5, he lands right there. And this point down 1, 2, 3, over 1, 2, 3, 4, 5, he lands right there. And this point down 1, 2, 3, hope you can see my little dots, over 1, 2, 3, 4, 5, and he lands right there. And then there's my answer. However, when you are in my math lab, this was number 11. I am almost out of time. Okay, so here's that problem. I was going to click to enlarge my graph. It's a parabola, so I click on him. I know I'm starting with that. All you have to do is click the graph and the y equals x squared shows up. And then I had to look at my equation, and all I did was a vertical shift. We went down 5, and then no, we didn't. I'm sorry. We went down 3. My bad. Go back. Down 3. And then there was a horizontal shift to the left 5. There we go. Boop. And that's where my new one should be. And save and check answer and get positive affirmation. I'm feeling excellent coming on. There it is. Okay, I am out of time. It's 5:15. I actually have, how many more do I have to go here? Oh gosh, I had quite a few more to go. I tell you what, I'm gonna just keep teaching this on the video here by myself. You can stay if you want, or you can leave, so that I can finish up on my examples. And if you want to come back and, I'll post it on YouTube, and you can come back and look at whichever one you think you might need help with in my math lab, because you may not need to see the examples. You might understand it and you're like, yeah, I can figure this out. So if you want to leave, bye-bye. But I'm going to sit here and keep the recording going and finish up those last few problems. So
will you post it tomorrow sometime?
Oh, I'll post it as soon as I'm done.
Okay, thank you.
It takes like 20 minutes to process it and get it loaded into YouTube.
Gotcha.
All right. Let's see, PowerPoint. Okay. All right, let's see. That was number 11. 13 is very similar, except on this one, it's not in the vertex form. It's in the standard form. So, I just need to figure out my new vertex. Yep. So I'm going to calculate x equals negative b over 2a. So that's going to be negative, and b is negative 6 over 2 times a, and a is this negative 1. So that's going to give me positive 6 over negative 2, which is negative 3. And then I'm going to take that and plug it into the equation f of x, which is really y, which is negative x squared minus 6 times x. X was negative 3. So I'm just going to stick that in there. So this is going to be negative 3 squared would be a positive 9. So it's really negative 9. Minus 6 times minus 3 makes that a plus 18, which makes that a 9. So my new equation is, when I put it in vertex form, y, or f of x, is going to be, it'll still have the exact same a, and a was negative 1. So I'm still going to have a negative here. But instead of x squared, it's going to be x minus the x coordinate, which was -3, and then plus k, and k is 9. But subtracting a negative is adding a positive. And now looking at this, I'm going to have to do 3 things. One, I'm going to have to flip it over because it's negative. And then the second thing is I'm going to have to shift it 3 to the left, since it's a +3 on the x. And the +9 means it's going to go up 9. It's going to go up 9. So the original graph, which, you know, would look something like this, is going to be shifted. First, it's going to be flipped upside down. I did that in blue, so that's upside down. Then for pink, it's going to be shifted 3 to the left. Since it's +3, I go left, so it's going to shift over here. And then for the yellow, it's going to go up 9. So from here, it'll go up to 9, which is approximately right here. So my yellow is actually what my final graph should look like. So if I go into my math lab, and this is number 13, let's see, new share, advanced, portion of a screen, share. Okay, there we go. I'm hoping you can see that. Anybody still out there? Anybody? Okay, I hope you can see this. I think I did this right. I'm going to click on it and click on it. Oh, wait, parabola. Then click on it. There's the original. We are going to, because of the negative in the front, it has to reflect around the x. So it flips upside down. Then we're going to do a vertical shift. It went up 9. So go over to, whoops, 9. And then I had a horizontal shift. It went 3 to the left. So -3. Boop. Lock it in place and check my answer. Well done. Woohoo. All right, I think I can just shrink that out of the way. Okay. Should still be seeing all this. All right. And then we go to number 15. Now, 15, actually, I had to do 1, 2, 3 slides to get it all in. On 15, it says, for the quadratic function, answer parts A through blah, blah, blah. Okay. First of all, does the graph open up or down? Because it is a negative x squared, that means it's going to be frowning at us like this. So that means it's opening down. Wants to know the coordinates of the vertex. So I'm going to have to do a little math there. The x coordinate is -b over 2 times a. So that's negative. B was a 6 over 2 times a is a -1. So that's -6 over -2, which is +3. They want an ordered pair. So I just got the x is 3. I am now going to take that 3 and plug it in here and here to calculate the y coordinate. So it's going to be negative of whatever x is squared plus 6 times whatever x is. X was a 3. So this is going to be a negative. 3 squared is 9. Plus 6 times 3 is 18, and -9 plus 18 is 9. So that's that. Then they want the axis of symmetry. That is simply x is equal to the x coordinate of the vertex. That's it. Then it keeps going. I couldn't get it all on one page, so I took another screenshot of the next part. It says, what is or are the X-intercepts? And it specifically says, type an integer or decimal, use comma to separate answers as needed. They do not want them in ordered pair form. So I have to remember that the X-intercepts, that is when y is 0. So I'm going to go to the equation, put 0 where y is, and the equation was negative x squared plus 6x. And then I did something funky. I actually added over my x squared and subtracted over my 6x so that my 0 was on the right. It is much easier to factor when your x squared is positive. In my professional opinion, you don't have to do that, but I did. I'm now going to factor out the x. That leaves me with an x and an x minus 6. So my two possible answers are for this x, it's just x is 0. And then for this x, it would have to be x is 6, because 6 minus 6 would be 0. So my two x-intercepts are 0, comma, 6. And then it says, what's the y-intercept? Well, remember the y-intercept is c. And when I look at this equation, I guess I'll use yellow, c right here, c is 0. So the y-intercept is, again, just a number, is 0. And then it says, use the graphing tool to graph the function. In my math lab, you'll only need to graph the vertex and one other point, which you can pick one of the x-intercepts or pick the y-intercept, whichever you want. Forgot what my vertex was, 3, 9. So the first point I would have to plot is, I'll do this in red, at 3, 9, so over 3 up 9 is this point right here. That's my vertex, 3, 9. And then I would just go with the x-intercept is 0 or the y-intercept is 0. That's the origin. And it should give you a perfect parabola. All right. Oh, but we're not done. It keeps going on. It says determine the domain and the range of the function. All right, well, my graph when I was done was at 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It was here. It came down and intersected here, and it also intersected at 6 over. No, 6, yeah. There you go. 6 over here, right? So if you're looking for the domain, it's a parabola. Parabolas stretch over the entire x-axis, so negative infinity to positive infinity. The range, however, goes from a high point. The range goes from the highest point right here, and then for this one, it's going down. So it's actually starting at negative infinity and stopping at the highest point, which would be the y coordinate of your vertex, which was 9. And yes, you include that, so use a bracket. When you get to the next part, which asks about determine where the function is increasing and where it is decreasing. Increasing on this one would be the left side, which would go from negative infinity up to the x coordinate of the vertex, which is 3, and you do not include it. The vertex is actually a turning point. You are no longer increasing, but have not started decreasing at that point. You're just hovering in midair, so you cannot include it. So you need parentheses on that. And then you're going to go for where it's decreasing, and that is on the other side, which means you start on the other side of 3 and finish up in infinity land. And that finished number 15. And then 17 is very similar. Took me 4 pages to get through this one. Find the vertex and the axis of symmetry of the quadratic equation and determine whether it's concave up or concave down. So for my vertex, once again, negative b over 2a. So it's negative b over 2 times a. My b is this negative 1. So negative 1, and my A is that positive 2. Oh man, this isn't gonna be fun. Positive 1 over 4. Type an ordered pair. So it does say type an ordered pair. So I'm gonna have to, do an ordered pair thing. The x coordinate is 1/4. Which means I've got to find the y coordinate. Okay, so the y coordinate is going to be 2 times x squared minus x plus 5. And I have to stick the 1/4 in there. Fun times. Let's see, 1/4 times 1/4 is 1/16. And then I'm actually going to cross cancel 2 in itself once and 2 into 16 8 times. So that what I'm really getting here is 1/8. So now what I have is 1/8 minus 1/4, but for 1/4, I want to multiply top and bottom by 2. So that's going to make this 2/8 plus, and 5, which is really 5 over 1, I would multiply top and bottom by 8, which makes that 48. And now I just have to mess with the numerators because the denominator is 8. 1 minus 2 is -1, and -1 plus 40 is, yuck, 39/8. Yuck. All right, the axis of symmetry, you've already got the answer. It is the x coordinate of the vertex, so x equals 1/4. And because my A was a positive 2, this thing is smiling, so it's concave up. Okay, then it moves on. It says, what's the x-intercepts and what's the y-intercept? The y-intercept is easy. That's just C, which was the 5. So for the y-intercept, that was 0C, which is 0,5. The x-intercepts, unfortunately, oh, wait a minute. The x-intercepts, remember this thing is a smiley face. Yeah, I'm not even going to attempt the x-intercepts until I make sure I have some, because our vertex was at positive 1/4, positive 39/8, and this thing was smiling at us. My vertex, if x is positive and y is positive, that point is in quadrant number 1, and it's smiling at you. There are no x-intercepts. And I'm now looking for my choices down here. The only parabola that has a vertex in quadrant 1 and is also smiling, this one's out because it's upside down. This one's out because it's upside down. This one, the vertex is right there. This one, the vertex is way the heck over in quadrant 2. It's got to be A. It's got an x of 1/4. So yeah, it's real close to the origin. If you click on the little magnifying glass there, you'll be able to see it much better. But A is the correct answer. And then what I did is I took a picture of A so I could draw on it for the domain and the range and the increasing and the decreasing. domain for all parabolas is always negative infinity to positive infinity. The range, however, the lowest point is right here, and then it goes to infinity. So the range is the lowest point on the y was 39/8, and you do need a bracket for that. So the 39/8, and then it goes to positive infinity. And then let's go lime green. For increasing, in this picture, the increasing is on the right side. Now, increasing and decreasing, you use the x coordinate, and the x coordinate was 1/4, and it's going uphill to the right towards infinity. The decreasing is on the other side. So that one's starting at negative infinity and going to 1/4. And I'm still not done with 17, because now it says determine where the function is greater than 0 and where the function is less than 0. Okay. Since f of x, go with green this time, they're saying f of x. They're wanting to know where is the function greater than 0. We're looking for every point that has a y coordinate that is greater than 0. They all do. Every single point on this graph, if you look at its y coordinate, their y coordinates are all above the origin. All points have a y that's greater than 0. So f of x is greater than 0 on, and f of x is never negative. They're all greater than 0, so it's this one. And type your answer in interval notation. So it's on the entire domain of negative infinity to positive infinity. Yeah, type it in interval notation. So for the entire domain, the function is always positive and it's never negative. Which brings me to the last one, last two problems. 19, determine the quadratic function whose graph is given. Okay, type an expression, and this is the one I wanted to go into my math lab and check to see if it'll take my vertex form, because all I did was calculate the x coordinate is, oh, I'm sorry, I don't have to calculate anything. It's right there. Remember, the vertex form is y equals a times x minus h squared plus k, and I just lied, I do have to calculate something. I'm gonna put the 3, that's gonna go here, it's a positive 3, and the negative 10 is gonna go where the k is. I don't know what a is. I do not know what to put what a is. However, I was given an ordered pair. I was given this ordered pair that has an x coordinate of 0. So I'm going to put that right here. And I was given that same point has a y coordinate of -1. And that's what's going to go right there. Once I plug all those in, I can figure out a. So purple was -1, leave a in there. Green is 0, minus pink is 3, and plus K would be a minus 10. So 0 minus 3 is a minus 3. Negative 3 squared is a positive 9. I'm then going to add 10 to both sides. That's going to give me 9 equals 9a. And so that means a is equal to a 1. So it would be my y is going to be 1 times x minus 3 squared minus 10. You'll notice they have f of x, and then 1 really should be invisible. So x minus 3 squared minus 10 is my answer. Did I do that already? I'm trying to remember. I'm going to jump over to my math lab. This is number 19. Oh, yeah, I did. I already did it. Yep, it took it. X minus 3 squared minus 10. Okay, I'm not going to show you that because I know the answer is correct unless you just saw that, which you might have since I'm sharing a different screen. And last but not least is number 22. It says determine without graphing whether the given quadratic function has a maximum value or a minimum value. This is actually a drop-down box. I took a screenshot of my printed out version. So you'll have a little drop-down box here, and when you do it, this is your choices. This one's easy. A is equal to a 2, and A is greater than 0. So A looks like this, which means A is a minimum. And now I'm done. Thank you. You've been a lovely audience. Is anybody out there? Close. Ah, Amber Ray, you're still with me. Are you awake? Amber Ray, are you there? You stayed the whole time. Did you walk away? All right, I'm shutting her down.